This video is part 1 of 2 dealing with the unit circle. This is a very important part of the course and one you really need to listen to and pay attention. This will talk about the angles between 0 and 360 degrees on the unit circle, as well as those same angles but in radians. We're going to be paying particular attention to our special angles, 30 degrees, 45 degrees, and 60 degrees. We've seen this picture before. We talked about how if we had a unit circle, the positive x-axis would represent 0 degrees, our positive y-axis would represent 90 degrees, our negative x-axis would be 180 degrees, and our negative y-axis would represent 270 degrees. But what I want to do is start putting on here not just these 4 angles, but also 30 degrees and 45 degrees and 60 degrees, because those were the angles that we needed to memorize. And then also, if we look at the other quadrants, quadrants 2, 3, and 4, what angles should we look at there? Well, those would be angles with 45, 30, or 60 degrees as reference angles, because those are also ones we can find exact answers to. So let's move to a bigger picture. So if this is our unit circle, and I go ahead and fill in the 4 angles we've just talked about, 0, 90 degrees, 180 degrees, and 270 degrees. And then we go and put in our 3 other angles that we know. 45 degrees, that's halfway between 0 and 90, as well as 30 degrees and 60 degrees. Well, we don't want to limit ourselves to just these acute angles in quadrant 1. So we want to also look at these same angles in the other quadrants. For instance, this angle, 135 degrees. If we looked at that angle, and I asked you what the reference angle would be, you would take 180 degrees, subtract 135 degrees, and you'd get a reference angle of 45 degrees. So 135 degrees has a reference angle of 45 degrees. And that's quadrant 2. We could do the same thing in quadrant 3. An angle with a reference angle of 45 degrees in quadrant 3 would be 225 degrees. I found that just by adding 45 degrees to 180. And in quadrant 4, 315 degrees has a reference angle of 45 degrees. Well, now that we've taken care of the 45 degrees, we have to look at 30 degrees and 60 degrees as well. Let's look at this one first. Let's see, 120 degrees. That's 30 degrees off of 90 degrees, and that would give us a reference angle of, let's see, 180 minus 120. That would be a reference angle of 60 degrees. The other angle in this quadrant would be 150 degrees. That's an angle with a reference angle of 30 degrees. And we can keep going. In quadrant 3, our next angle with a reference angle of 30 degrees would be 210 degrees. That's 180 plus 30. Our next angle would be 240 degrees. That would have a reference angle of 60 degrees. And finally, quadrant 4, we have an angle of 300 degrees. That would give us a reference angle of 60. And our last angle would be 330 degrees in that 4th quadrant, and that would have a reference angle of 30 degrees. Alright, well that's degrees. Well, we also have to worry about radians. Let's first put in our 4 radians that we know. We know 0 radians, we know pi over 2 radians, we know pi, and we know 3 pi over 2. Well, now let's concentrate on the first quadrant. We'll start off with 45 degrees. What is 45 degrees in terms of radians? Well, 45 degrees is halfway between 90 degrees and 0 degrees. So if we look at, instead of 90 degrees, if we looked at pi over 2, half of pi over 2 is pi over 4. Well, that makes sense. We can also do the same calculation using our unit fraction. If we want to convert from 45 degrees to radians exactly, all we do is multiply by the unit fraction pi over 180 degrees, and that simplifies to pi over 4, as we've just found. There's 2 other angles to worry about, 30 degrees and 60 degrees. Well, let's take those and convert those to radians. When we convert these numbers to radians, 30 degrees becomes pi over 6, and 60 degrees becomes pi over 3. The way I remember this is I have 30 degrees and 60 degrees. 30 degrees has a denominator of 6, whereas 60 degrees has a denominator of 3. It's just a quick way I have of remembering which denominator goes with 30 degrees and which goes with 60 degrees. So I've put that into my unit circle. But now we have to look at the other quadrants. Let's first take 120 degrees. If I wanted to convert 120 degrees to radians, I would multiply it by the same unit fraction, and that simplifies to 2 pi over 3. If I go ahead and put that in my unit circle, then I'll spare showing you how I converted 135 degrees to 3 pi over 4 and 150 degrees to 5 pi over 6. The third quadrant will do exactly the same way. I'll take my angles in degrees, multiply it by my unit fraction, pi over 180 degrees, and I find that in this quadrant we have the angles 7 pi over 6, 5 pi over 4, and 4 pi over 3. Doing the same thing to the fourth quadrant leaves us with 5 pi over 3, 7 pi over 4, and 11 pi over 6. Now what I'm going to say now might surprise you. What I'd like you to do is memorize this unit circle. I think it's pretty easy to quickly sketch out the degrees for a unit circle, but you'll find that exams will go much easier if at the beginning of the exam you spend a few minutes and sketch out this unit circle. Sketch out the degrees and then fill in the radians. Well, how am I going to remember the radians? Well, first of all, in quadrant 1, you're just going to have to memorize these, but I think they're pretty easy. As I said, I've told you my trick for 60 degrees and 30 degrees, how I remember which one's pi over 3 and which one's pi over 6, and pi over 4 is pretty straightforward to remember as well. But if you look at what happens in the second quadrant, if you know where the denominators go, and they just match up, you'll notice that at 60 degrees and 120 degrees, both of those angles, which would both, by the way, have a reference angle of 60 degrees, they both have a 3 in the denominator. So if you can remember the denominator, there's a trick I can show you. In the second quadrant, if you take that denominator, subtract 1 from it, then that's your new numerator. So for instance, what we just did with 120 degrees, we know the denominator is 3, 3 minus 1 is 2, so that angle is 2 pi over 3. The same thing works with 3 pi over 4. If you know that the denominator is 4, subtract 1 from it, get 3, so you have 3 pi over 4. There's a different trick for quadrant 3. For quadrant 3, you take that denominator and add 1 to it this time. So 210 degrees, which you know is something over 6, 6 plus 1 is 7, so in radians it's 7 pi over 6. In the fourth quadrant, what we'll do is take that denominator, multiply it by 2, and then subtract 1 from it. So for instance, 330 degrees, that denominator is 6, 6 times 2 is 12, minus 1 is 11, and our result is 11 pi over 6. With a little bit of practice, you'll be able to quickly write out the radians for the unit circle, and believe me, it will make your test go much faster and much less work.